Hello, this is Mr. Collier, and today we're graphing rational functions with quadratic denominators. Okay, in the first example we've got this function, and very importantly we need to first figure out what the asymptotes are. That'll help us with graphing. So it has vertical asymptotes when the denominator equals 0, and solving that we get x equals positive negative root 2 are our vertical asymptotes. Our horizontal asymptotes, well, this occurs when x gets really, really big. What number is it approaching? We call that the limit as x tends to infinity of f of x. So as x gets really large, what happens to the y values basically? So this equals limit as x tends to infinity of, and we take the highest power of x and divide everything by that, and we get 5 over x over 1 minus 2x squared. Okay, so it's like I multiplied the numerator and denominator by 1 over x squared, and I got this, right? So this denominator gets really, really huge. This number approaches 0. And this approaches 0, so the whole thing, the limit is 0. So we have a horizontal asymptote at y equals 0. So we have that. Y equals 0 is an asymptote. We have x equals negative root 2. X equals root 2 are our vertical asymptotes. We can get the y-intercept by just plugging in x equals 0. So this is the y-intercept. And x-intercept, we set this equal to 0. We also get the same point, so 0, 0 looks like our intercept. So let's take a look at what's happening when we get close to root 2, get close to this asymptote. When we get close to root 2, let's see what happens when we plug in 1. If we plug in x equals 1, we get negative 5 over we get negative 5 over negative 1, which is positive 5. So at x equals 1, which is over here somewhere, we got a positive 5. So next, let's try over here. Let's see what's happening close to this asymptote here. If we plug in a number like negative 1, we'll get positive 5 over negative 1. We get negative 5 over here. And they'll get closer and closer to the asymptote here. So it's going to look something like this. Yeah, on the other side of root 2, we'll plug in some positive numbers like the number, well, I guess number 2 maybe. So we plug in positive 2. We're going to get negative 10 divided by positive 2. We're going to get negative 5. And if you plug in like positive 5, you're going to get 25 out of negative 25 out of 23. You're going to get closer. You're always going to get a negative number when you plug in a number bigger than x equals root 2, right? So they're going to become smaller and smaller numbers. So you're going to go something like that. And it's never going to become positive, so it's going to approach 0. Okay, on this side, if we plug in a number like negative 2, we get positive 10 over 2. You're going to get like positive 5 over here. So this is going to be shape over here. You're always going to get positive numbers, and it's going to approach the asymptote right here. So this is kind of what our graph looks like. Okay, next one we have, this is just a quadratic on the denominator. So I can factor the denominator, then I can see more clearly where the vertical asymptotes are. So you're going to have a vertical asymptote at x equals negative 3 and x equals 2. Horizontal asymptote is going to be 0, because the limit as x goes to infinity of the function is 0. Okay, since the denominator gets really, really large, the whole function gets closer to 0. And we've got that. We can plug in 0 to get the the y-intercept. Plug in x equals 0, we get the y-intercept is negative 2/3. So there's the y-intercept. Let's maybe graph the original quadratic, and then we'll do the reciprocal of that. So this quadratic here it's got intercepts at 2 and 3. Okay, so it's going to look like that. We'll have a vertex over here somewhere, and then like that. So 1 over that, you're going to get your, I guess we could have got our vertical asymptotes right from there. So that's x equals 2, x equals 3, because 1 divided by 0 gives you a vertical asymptote. Here, 1 divided by, let's do this in red. Okay, 1 divided by a really small number gives you a huge number. These are all positive, so you're going to get positive numbers here. And you're going to get a similar thing happening over here. And over here, we already know this point is on this graph. Your vertex is going to be flipped to right here, and you're going to have this kind of shape. Okay, so we can label this as 0, negative 2/3. And there's no other intercepts. And I guess that's it. Yeah. Oh, you can also say y equals 0 is the horizontal asymptote. Okay, next let's look at these two functions. And here it looks very similar to a, so I think we're going to have a fairly similar shape. But let's get the vertical asymptotes first. I'll draw it over here. So the vertical asymptotes are positive negative 3. Horizontal asymptote, as x tends to infinity, y goes to 0. And y-intercept is going to be plug in 0, you get 0, so it's going to be 0, 0, and the x-intercept as well is going to be same. So it's going to go through this point. Let's draw in these asymptotes. X equals 3, x equals negative 3, y equals 0, and when x is a number like 1, we're going to get 1 over negative 8, so negative 1/8. And over here we're going to get positive 1/8 when x is negative 1. And the numbers are going to go like this, I believe. So we have this shape. And here we have 3, so after that we have 4. 4 over 16 minus 9, we're going to have a positive number over here. Okay, so the numbers are going to be approaching this asymptote, and they're all going to be positive over here. And numbers less than negative 3, we're going to get a positive denominator. You're going to have a negative numerator, so they're all going to be in this region. They're all going to be negative to the left of negative 3. So that's what our graph looks like. We can label this point as well, and that's everything labeled. Okay, let's take a look at this one. This equals 2x over x minus 4 times x plus 3, so we can get our vertical asymptotes from that. 1, 2, 3, so at negative 3 we have a vertical asymptote. At 1, 2, 3, 4 we have a vertical asymptote. Horizontal asymptote. Well, you can do the limit as x tends to infinity of 2x plus 8 over x squared minus x minus 12 equals, divide everything by x squared. I have 2 over x plus 8 over x squared over 1 minus 1 over x minus 12 over x squared. And all these terms go to 0, so you're going to have 0 over 1, which equals 0. That gives you the horizontal asymptote of y equals 0. And the y-intercept, we can plug in x equals 0. We're going to get negative 2/3 is your y-intercept. Okay, so we have negative 2/3. I'll try this 8 up here. What happens when we plug in a number like 1? we have, we're going to get, well, let's use this version. Plug in a number like 1, you're going to get 10 over a negative number. You're going to get negative 4. Okay, so you're going to have negative 2.5. So you're going to have something like that. So these numbers are going to go approach the asymptote down here. And over here, you plug in a negative number, you're going to get positive on the top here. You're going to get negative. You're also going to get negative numbers, right? If you plug in numbers like negative 1. So this is going to go this way. So that's what it looks like in that section. Over here, you have x equals 4. After x equals 4, you plug in numbers, and this part here becomes positive. So the whole thing is positive. So all numbers are going to be positive in this section. So it's going to look like that. Okay, we should have gotten the x-intercept earlier. Let's get the x-intercept now. 0 equals the function, means the numerator has to be 0. So the x-intercept is actually at negative 4. So that helps us out. We're going to have an x-intercept at negative 4. But between 3 and between negative 3 and negative 4, we're going to have positive numbers, because you plug in a number between negative 3 and negative 4, you're going to get a positive numerator. You're going to get negative times negative down here is positive. You're going to have positive numbers. So the asymptote goes like that and touches 4. And as x goes to negative infinity, it's also approaching 0. So it's going to look like this. It's going to come back and peter out and go towards 0. So that's what the function looks like on the left-hand side. Okay, the next example, let's graph this function. There's no vertical asymptotes. The denominator is never 0. We can plug in and get the y-intercept. Plug in 0, and we get 0. Okay, actually, let's use our calculator to graph this one. Okay, so we have 25x divided by x squared plus 4. Okay, let me delete this one here. Okay, so I'll graph that. Now the function has a domain of t greater than or equal to 0, so I just need the positive part actually. So it's going to go up like this, and then looks like it comes down to this. It's got a horizontal asymptote at y equals 0. So this is time, and this is c as a function of time. When does the highest concentration occur, and what is it? On the graph, we can do second calc intersect, or sorry, that's not right. We want to find the maximum. So that's number 4. Alright, go to the left, go to the right, and okay, so what was that? Oops, went too quickly. So there it goes. It looks like about 2 and 6.25. Okay, so it happens after 2 minutes, and it is, and the concentration is 6.25 milligrams per liter. Okay, what will eventually happen to the concentration? Well, it's going to approach 0. The concentration is going to get closer and closer to 0. And how long does it take for the concentration to be below 0.5? Well, we need to graph the line y equals 0.5 and find that point of intersection. So let's do that. And I think I'll need to change my window. Change X max to be bigger because I didn't see it go down that far yet. Okay, looks like it might intersect over there. Number 5, and let's go a little bit closer to it, then it'll be quicker. Enter, enter, enter. So we get 49.9. Okay, so it intersects there at 49.9, comma 0.5. So after 49.9 minutes,